have selected. It depends with the function you want to test. So I cannot decide yet. Okay. But for your midterm, I will choose one pair of this technique. And also for your final exam, I will choose one pair of the technique. One pair. Okay. So whatever you will see on your midterm, it will not come again in your final exam. Okay. I already give you this information. Okay, so let's move to each of these techniques. Okay, so the first one is the equivalence partitioning. So when we said equivalence partitioning, it means we want to have a partition of classes, partition of data. Okay, so this will be giving us the possible input data based on the partitioning. Okay, so later we will see how we can identify the partitioning. So this partitioning also can be called as a equivalent classes or the equivalence partitioning. Okay, so this equivalent class is actually a set of data values which we will use for our testing. Okay, so let's assume we want to test a function. So we have a set of data. So we have three different equivalent classes, for example. So the first class, okay, this is a set of value. Second class, this is the set of value. So there is a partitioning happen. Okay, so from each of this partitioning, so let's assume that because we cannot control the number of data values, so we don't need to test every possibilities of data values. So according to each of these partitioning, we just need one representative of the input data of each classes. So let's assume, I think in a class I have shown you like, okay, there is a text box and this text box accepting a quantity. Okay, so when I said the text box able to accept the quantity of 1 until 100, so it means I can have a partitioning where my first partitioning is the valid partitioning. Valid partitioning means any values from 1 until 100, it is categorized under the valid partitioning. So instead of testing the same text box for 100 times, I just pick one representative input data and I test. For example, I pick 10. Okay, so no matter how many times I'm repeating the same test, whatever value from 0 to 100 is going to give me the same result. So instead of repeating the same test for 100 times, I just pick one representative for this range. Okay, so after the first partitioning, I can have my second partitioning. So it means whatever below 0, it is called invalid partitioning. So I choose one representative value from there and to test what happened. Then the same thing goes, my third partitioning, when I give any value more than 100. So if I give 200, what happened? So the third partitioning, I pick one representative values. So instead of having a lot of repetition test case, I just need 3 test case to test one valid value, and I need 2 invalid value. One is below the minimum value, one is more than the maximum value. I'm done. So sometimes we cannot just guess this way. So we need to have a proper equivalent class partitioning to see this. Then from there, we will pick the value. Okay. So first what we need to do is we will do for the correct input. It means we will do for the valid classes first, and then we will follow by the invalid classes. So it means we will have the valid values and then we have the invalid values. Okay, so there will be two steps how we can use this technique. So the first one, we need to identify the equivalent clauses. Then the second one, we need to define the test cases. Okay, so normally these equivalent clauses, to use these equivalence partitioning techniques, okay, we need to identify the equivalent clauses based on the requirement given. Okay, so normally this technique will be suitable for any requirements which give us a range of values. Okay, so this is what I was saying just now. If the item count can be from 1 to 999, so I can have one valid equivalent class, which is mean from 1 to 99. So it means we use this expression using less than, greater than. These symbols will be needed. Please do take care of that. Okay, then we can have two invalid clauses where one is below the minimum value and one is more than the maximum value. So this is normal situation when we can use this equivalent clause. So other than that, we can also use it when the requirement sounds based on condition on numbers of values. For example, if you see 1 through 6 honors can be listed for the automobile. 1 through 6. So it means I can have one valid equivalent class, okay, where anything from 1 to 6, and then I can have two invalid equivalent class where I can have 0 honors as an invalid. Another one is when it's more than 6. Okay. Other than that, let's see other situation where if the input condition specify a set of input values. So a set means, okay, a set of where, for example, they have given this, where they give each of these, bus, truck, and then taxi cab, passenger, motorcycle, or. So if in this situation, we can identify a valid equivalent clauses for each of them. So this is a valid, this is valid, valid, valid. So we have total of 1, 2, 3, 4, 5 valid clauses. It means each of them considered valid, and we can have one invalid because anything other than these 5 terms, it's considered invalid. Okay, so we can test 5 of valid equivalent class and one invalid. It means anything else other than listed here. Okay, then other than that is a must be situation. Must be situation means it must follow what is given. So for example, first character of the identifier must be a letter. Okay, the first. So what will happen? We have one valid equivalent class where it is fulfilling the given situation where it must be a letter, and we have one invalid equivalent class when it's not a letter. So this is how from the requirement we decide to have how many valid clauses and invalid clauses. Normally the statement will give us the valid requirement first for us to identify the valid clauses. Once we identify the valid clauses, from there we can identify the invalid clauses. Okay, got it? So after we identify the clauses, okay, then we will do the second step, which is define the test cases. Okay, so define the test cases means each of the partitioning which we will do, we actually need to assign a unique number. Okay, so we will do later, and then we will actually do all the valid equivalent classes first. Okay, then after that we will actually do the invalid equivalent classes. So normally we will do a table format. Okay, so I already give you one example of requirement and also the answer in a table format. Okay, so let's see this requirement. This is a natural language requirement. Okay, for a sales price of less than $15,000, no discount shall be given. For a price up to 20,000, a 5% discount is given. Below 25,000, the discount is 7%, and from 25,000 onward, the discount is 8.5%. Okay, EC stands for equivalent classes. Okay, so from the given requirement here, like what I said, requirement normally giving you the valid classes. It means what data will be valid. Okay, so if you see here, how many classes we can have, how many valid equivalent classes we can have. From the statement, we can see the range given, and there is discount happen. Am I right? If you see, the first one is zero discount. Okay, then you see 5% discount, and then you see 7% of discount, and then 8.5 discount. So this is actually our expected output. Okay, so for this range, this is the expected output. So if you see, we actually can have 4 equivalent classes here, 4 valid equivalent classes here. Okay, so let's see the next slide. So this is how the table can be, but the table is missed the output. So normally we have another one more column to put back the output. Okay, so if you see, like what I said, we have 4 valid equivalent classes. Okay, from the statement here, you can see the parameter which we are using is sales price. It means based on the sales price, we want to know what is the discount. Okay, so for the first statement here, for a sales price of less than 15,000, less than 15,000, no discount shall be given. So if you see the first one, can you see the first one? Okay, VEC is stand for valid equivalent class 1. Okay, V stand for valid equivalent class 1. Okay, based on my first, I put this as the first class. Okay, so the given range here is 0 to 14999, because the statement said less than 15,000. So it means 15,000 is not counted here. Okay, so it means if there is no sales happen, 0 to 14999, there will be no discount or 0 discount happen. This is the first statement. So we have the first valid equivalent class, and we pick one representative value which can fulfill this range. My range is minimum is 0 and maximum is 14999. So this is within that range. And what should be the expected output? The expected output is 0 discount. Okay. Can understand how the first statement come? How the first valid equivalent class 1 come? V stand for valid, EC stand for equivalent class, and 1 is the unique number. So for each of these class, we will label them 1, 2, 3, 4. So it means they are unique. Okay. Can understand how we get the first one? Please do let me know if everyone is okay or not. Okay, so let's see the second one. So the second statement here, for a price up to 20,000. Up to 20,000 means what is the minimum? Where is the minimum start? Up to 20,000 means where is the minimum value start? Is it start from 0 again? 15,000. Okay, because the first class just now is less than 15,000, which was 14999. So the minimum for the second valid equivalent class will be start from 15,000, and they say that for a price up to 20,000, it means 20,000 is included in the second valid equivalent class. So it means from 15,000 to 20,000, what is the representative value? We choose 1. Okay. Then the third one is below 25,000. The discount is 7%. So below 25,000 means it will be from 20,001. Can you see this one? The second class is until 20,000, right? So the third valid equivalent class will start from 20,001 until 24,999, because they said below 25,000. Okay, so the discount will be 7%. Okay, then the last statement say that from 25,000 onward. Okay, I'm highlighting all this. Okay, so from 25,000 onward. Okay, can you see here? Do we have any maximum value? Do we have any maximum value? There is no maximum of sales price given. Okay, so that's why you can see it's actually more than equal to 25,000. Okay, but when it comes to your assignment for your midterm or for your final exam, even though if the requirement did not give you the maximum, we will put one maximum value. Any value which you think is like illogical at all, this can never be. For example, let's assume the sales price, right? They say 25,000 onward. So let's see, like 100,000 is the maximum value we can accept of one sales price. Cannot go more than $100,000. Let's assume. So we must put the maximum value here. It means we have a minimum start from 25,000 and the maximum we put 100,000, because let's assume later when we want to bring this for the continuous technique, which is the next one, boundary value analysis, we need to have this boundary. We must know what is the minimum value, what is the maximum value. Okay, so in that case we actually must have the maximum value here. So this example do not have that, but in our way, for example, in our class, in our assignment, in our exam or later, we must indicate the maximum value. So let's assume if we say 25,000 onward and we have stopped the sales until 100,000. So it means we have the pair of values here. It means 25,000 less than equal to X, and then it will be until less than equal to 100,000. So anything more than 100,000 we consider it is invalid. Okay. Can understand how we get this table? So actually there will be another one more column for the output, expected output. So our expected output is zero discount, 5%, 7%, and 8.5%. Okay. Got it? Can understand? Can understand how we get this valid clauses first. Okay, so once we get all the valid clauses from the requirement, okay, from here we can know that, okay, we have identified 4 different valid equivalent clauses, and from there we have 4 different input representative which we can use for our testing. So it means for this given requirement, I have 4 different test cases to test them. Do you get? So I have 4 valid test cases. It means I have 4 positive test cases which will test 4 valid values where each of them from individual partitioning or individual equivalent clauses. Okay. Can that is valid. So once we done with the valid equivalent clauses, then we can move to invalid equivalent clauses. Okay. Sorry, can we use this as the maximum? Just now I said 100,000, right? Okay, so we can use this as the example for the maximum. Okay, so for invalid, the same thing, the same structure of the table, the same thing, but can you see the difference is IEC. So IEC stand for invalid. Yes. So invalid equivalent class 1. Invalid equivalent class 2. So if you see from this table, we can already see we have 2 invalid equivalent classes where one which is less than the minimum. Our minimum is 0. Anything below that we can consider as an invalid. And just now we have decided that the valid equivalent class for, we will have the maximum. So can we use this as the maximum? Okay. So anything more than that, it's also categorized as an invalid equivalent class. So from here, we can already know I have 4 valid data to test and I have 2 invalid data. One is below the 0, one is more than 100,000. Is it 100,000? Okay. So we just need total of 4 positive test case to test the 4 values, and then we need 2 negative test case to test by using these invalid values. So for the column for the expected result, when it comes to invalid equivalent class, we actually cannot have any discount, but we will have the error messages. So for example, the error message display out, okay, it's a wrong sales price. Where got sales price in negative? Okay. Then anything more than the maximum, we can put, oh, this is unrealistic high sales because you buy more than our maximum of the amount which we can give for discount. This is unrealistically happen. So we cannot count the discount, for example. So we will have a simple error message under the expected column, expected output column. Got it? Can I understand how we get these 2 tables from our requirement? So now for your assignment, we will not have requirement. Remember, it is a completed system which is currently working in a market and there is no documentation being shared with you. So let's assume for you to identify the number of test cases, you actually need to understand the functionality. So remember, each person you need to select 2 functionality. So from that functionality, if you can see, it is providing something with the range like this. Okay, from this to this, from this minimum to this maximum value. It means it is suitable for you to use this equivalence partitioning technique, where you can clearly divide the classes based on the minimum and maximum value for each of the class range, and also anything below the minimum and anything more than the maximum, you can see it is fall under the invalid equivalent classes. Okay, got it? Can understand how this technique work? This is the first technique, the first black box testing technique. Okay. Can understand? So this is actually more to the how to say, the the requirement is actually using more to digits, I mean the values in numbers, where we can actually see, okay, this is the range, this is the minimum range, this is the maximum range. So let's assume if your requirement, I mean your functionality, it's more to not like using values, then it will be difficult for you to use this partitioning technique. So you need to use the other side, which is the logic based technique. Got it? Do you get what I'm saying? some functionality